Regarding correlation measures for the four selected copulas, we observe different relationships between correlation coefficients, such as Kendall's tau and Spearman's rho, and the copula parameters, rho and Kendall's tau. Some cells in the column for Kendall's tau and Spearman's rho contain formulas that show how these correlations depend on specific parameters of the given bivariate copulas. In the first two rows, we see how tau depends on rho, which is characteristic of elliptical copulas. Meanwhile, in the last two rows, we observe how tau depends on the theta parameter, which is characteristic of the Clayton and Gumbel copulas. For Spearman's rho, the relationship is relatively straightforward for the Gaussian copula. However, when it comes to the student's T copula, the Clayton copula, and the Gumbel copula, explicitly showing the relationships between Spearman's rho and the copula parameters is more complex for various reasons. One can say that in the case of the Gaussian copula, if rho, the characteristic parameter of the bivariate Gaussian copula, increases, then Kendall's tau and Spearman's rho also increase. A similar relationship holds for the student's T copula. As rho in the bivariate T copula increases, Kendall's tau and Spearman's rho also increase. For the Clayton copula, an increase in the theta parameter results in an increase in both Kendall's tau and Spearman's rho. These are positive dependencies, meaning that if theta were to decrease, Kendall's tau and Spearman's rho would also decrease. Similarly, for the Gumbel copula, an increase in theta leads to an increase in both Kendall's tau and Spearman's rho.